Hello, Math 135. This is Tracy. Welcome back. We are in Chapter 7 and we are going to do another example. From another free online stats text we have, an automobile battery manufacturer claims that its mid-grade battery has a mean life of 50 months with a standard deviation of 6 months. Suppose the distribution of battery lives for this brand is approximately normal. Assuming the manufacturer's claims are true, we have three questions. 1. What is the probability that a randomly selected battery of this type will last less than 48 months? A randomly selected battery of this type will last less than 48 months. Number 2 asks us, what is the probability that the mean, in number 2 we're looking at the mean of a random sample of 36 such batteries will be less than 48 months. And then number 3 asks us 97.5% of the time the mean for 36 randomly selected batteries will be above what value? So we have three different questions here, and we are going to go ahead and answer them in the next couple of pages. As before, we will be looking at two normal distributions. The first distribution we look at is the population distribution, and that is going to be the little short, stubby normal distribution. And that distribution has a mean of 50 months and a standard deviation of 6 months. That's the information that we were given. The second normal distribution we'll be looking at is the sampling distribution of the sample means. We get that from the central limit theorem. It says if you take a whole bunch of averages of, well, in our case size 36, the distribution for those means will be approximately normal with a mean of 50 months, same as the population, and a standard deviation that is much smaller. It is the standard deviation of the population distribution divided by the square root of the sample size. That makes it much taller and much skinnier. So our first question, here we were looking at the probability that a randomly selected battery of this type will last less than 48 months. So here we have our population mean, and here we have that our population standard deviation is 6 months. So when we look at 48, if we want to know the probability that a randomly selected battery lasts 48 months or less, we're looking at something just below the mean lifespan, and we're saying what's the probability that happens? We want the area that's shaded in. So we go into our calculator and we use the normal CDF. We want the probability that a single battery has a lifespan of less than 48 months. We use the normal CDF, and we're going to here use our lower bound. Now, we can either use 0, because no battery can last less than 0 months, or -10 raised to the 99. Both answers are very similar, so it really doesn't matter which one we use. Then we put in our upper bound of 48 months. That's the longest lifespan of a battery that we're interested in. Then we put our mean and our standard deviation. And notice we use the standard deviation for our population. Pop that in our calculator and we get an answer that is about equal to 0.3694. And that tells us that the probability a randomly selected battery lasts less than 48 months is about 37%. Now this is much different from our next problem. And in our next problem, what we are looking at is we are looking at the probability that the mean of a random sample of 36 such batteries will be less than 48 months. So again, we're looking at a normal distribution, but this normal distribution we are now looking at has, well, it's the same mean, even though it's the mean of the means, the average of the averages. But here, notice that our standard deviation for the means is now 1. And we get that standard deviation for the means by taking the standard deviation of the population divided by the square root of the sample size. So that's going to be our 6 months divided by the square root of our 36. That's our n. And when we do that, we get a standard deviation of 1 for the mean, the standard deviation for the sampling distribution of the means. So that goes right here. So again, we're looking at the sampling distribution of the means. We want to know the probability that our average for 36 batteries is less than 48. So again, we go into second vars to get to our distributions, and we scroll down to that normal CDF, type this in our calculator, our lower bound, our upper bound, our mean, and the standard deviation. And if we look here, we see that this area is much tinier than it was in the previous problem. And when we perform that calculation, we get that the probability is about 0.0228. And what this tells us is that the probability that the mean battery life for a random sample of 36 batteries, that the probability that the mean battery life for a random sample of 36 batteries is less than 48 months is about 2.28%. This tells us that either we got an unusual sample, only about 2.28% of samples will have a mean this small or smaller, or the information we were given to begin with is wrong. Maybe that mean battery life or standard deviation for battery life given us to the manufacturer are incorrect. Either we got a rare sample or the information we assume to be correct actually isn't. All right, now we're going to answer question number 3. Here we want to know not a probability. We are given a probability. We want to know if 97.5% of the time we get a mean above a certain value, what is that value? So we look at a normal distribution graph, and again, this is going to be a sampling distribution for the means because we want to know the probability that the mean is above a particular value. So again, we have that we are using a standard deviation for the means. Now, if we want to know the value that has 97.5% of the means above it, that means it has 2.5% of the means below it. And this is what our calculator can figure out for us. We want to find a data value, not a probability. We are given a probability. This is like finding a percentile. What we're really looking for is the 2.5th percentile. So that goes into our calculator. Again, under distributions, we scroll down to the inverse normal. But the first number here is always going to be the area to the left, or the percent below, which is also known as the percentile. So if we want to have 97.5% of the means above, we have to put in what percent of the means will be below the value we're looking for. So we get that from our 1 minus 0.975. So we type that into our calculator, inverse normal, area to the left. And again, we use our mean and our standard deviation. And our standard deviation is the standard deviation for the means, not the population. Type it in, and we get 48.04. And that's very consistent with what we got for our last problem. Our last problem said that 2.28% of the time, the mean will be 48 months or below. Here, this is saying 48.04 or below will be the mean 2.5% of the time. A little bit higher mean for a little bit longer of a mean lifespan. All right, about 97.5% of the time, the mean battery life for 36 randomly selected batteries will be about, not above, will be above 48.04 months. About 97.5% of the time, the mean battery life for 36 randomly selected batteries will be above 48.04 months. Not a percentage, not a probability. This time we found how many months give us this probability. And again, this is very consistent with what we got for our last problem.